practice problems for the periodic trends. This is the ionization energy trend. I'm just putting IE, and I've put that on other talks. So ionization energy is to remove an electron. So I just put this. It's the amount of energy to remove an electron in the gas phase. But just think, remove an electron as we go through this process. So for the going down a column, remember there's a trend for going down a column or going across a row. So if we're going down a column, so say we're doing calcium, barium, strontium, they're all in the group 2A column. If I ask you to order it in increasing ionization energy, think about, I'm asking from the smallest to the largest. The smallest ionization energy means it's the easiest to remove. So, easiest to remove. So the easier it is to remove is based on the fact that that electron is farther away from the positive nucleus that's holding it in. So for calcium, barium, strontium, as you go down this column, the one that is the furthest down has the electrons that are the furthest away, the outside electrons furthest away from that positive nuclear pull. So the farthest one down of those three is barium. So it is easiest to remove an electron from a barium atom than the other two. And then as we go up, strontium is the next one up, and then calcium. And again, you're going from the easiest to remove to the most difficult, and that has to do with how close those valence electrons are to the positive nucleus, which is holding them in. So again, smallest ionization energy over here, easiest to remove. So easiest to remove, again, how far the valence electrons are from that positive nucleus. So as we go across, remember those electrons are being held more tightly as they go across because the radius is getting smaller. So the easiest ones to remove would be the ones to the left. So of nickel, bromine, and potassium, the one that's the biggest radii is the potassium. Those electrons are the easiest to remove. And then as we go across, we hit the nickel, which is a little harder to remove, and then the bromine all the way across. So most difficult to remove electrons because those electrons are being held tighter and closer to the nucleus. Those are the trends for ionization energy. For electron affinity, I gave a general trend for adding an electron, but there's so many exceptions. So what I want you to remember, other than doing problems with the electron affinity, is that those exceptions depend on, and you could look at the examples in the book, they depend on the orbital filling. So we did those orbital filling diagrams, and we would put those arrows in up and down, depending on if they were paired or not paired. There'd be different energies to them, and that affects the electron affinity. So that's all I need you to know for that.